Okay, so make sure you've read and understood what came before this. Here's our first example with finding the density of this granite. It gives us that it weighs 2,700 grams. This is the mass. And then you need to understand that density is equal to mass over volume. So they gave us the mass, it gave us the dimensions of the rectangular prism and is asking for the density. So for mass, we could plug in the 2,700. For volume, that wasn't given to us. So off to the side, I'm going to show my work for getting the volume of the prism. So since it's a prism, it's the big B times H. The big B is just length times width because in this case it's a rectangle. And what's the length and the width of the base is 20 by 5. So the big B here is 100. So the volume is the big B, which is 100, times the height of the brick, which is 10. So the volume is 1,000. So you first have to find the volume to then plug in here. So now we're able to find that the density is equal to 2,700 divided by 1,000 is 2.7. And usually you don't need to know units, but I want you to understand that the units for the mass is in grams. Since the dimensions for the rectangular prism are centimeters, the volume is cubic centimeters or centimeters cubed. So it's grams per centimeters cubed. How many grams each cubic centimeter of the object is determines its density. Okay, a loaf of bread. Here they give you the volume, they give you the mass, and ask for the density. So this is a very basic problem. You would just have to literally do density equals mass divided by volume. They gave you the mass, they gave you the volume, and then you would divide that and get 0.2 grams per cubic centimeter. So that one's very basic if they give you the volume as opposed to just giving you the dimensions. Okay, here, Jane threw a plastic ball in the pool. They give you the mass of the ball and they're asking for the volume. They give you the density. So again, understanding that volume, no, density equals mass over volume. You need to memorize this better than me. Okay. And here they gave you the density is the 0.5. They give you the mass is 125. They're asking for the volume. So I have to solve for x. I'll put the 0.5 over 1, cross multiply 0.5x equals 125. Divide both sides by 0.5. And I solve for x, which is 250. And in this case, it's volume. Since they give you that the density is in grams per milliliter cubed, I know that the volume is in milliliters cubed. Again, usually you don't need to know the units. I just want you to understand the formula. Here, a machine shop worker records the mass. So they give you the mass and they are giving you one side of the cube. They want the density. Okay, well, density equals mass over volume. They don't give you the volume, but they give you one side of the cube. So the mass I could put in as 176. I have to find the volume of the cube. So if one edge is 4, that is your length, your width, and your height. So volume equals, usually we do big B times H. If it's a rectangular prism or a cube, it's okay to replace that big B with length times width because we know that the big B is length times width whenever you're talking about a square or a rectangle. So in this case, I'm just being consistent and sticking with the same formula. 4 times 4 is 16. So the volume is 16 times the height of the cube is going to be the same as the other two dimensions, and I get 64. So I get 176 divided by 64, so there's just that extra step of getting the volume before we could find that the density is equal to 2.75. And here the mass is given in grams. The units are centimeters for the dimension of the cube, so it's per cubic centimeter or centimeter cube. And one last one. They give you the density of gold. So this is extra information we're going to use at the end of the problem. I was given a gold pyramid award. If the square base of the pyramid has an edge of 5 centimeters and a height of 6 centimeters, so again, they're giving you enough information to get the volume of the pyramid, but they didn't give you the volume. And here, they're giving you the mass. Is the pyramid in fact gold? If not, what are the reasons that could explain why it's not? So again, density equals mass over volume. So they gave you how much it weighed, 942. Now the pyramid is going to have a volume of 1/3 base times height. So I could find the big B first. The square base is 5 by 5, which is 25. And then to get the volume of the pyramid, I'm going to do 1/3 times that 25 times the height, which was 6. And that gives us a volume of 50. So I'm going to divide 942 by 50, which I hadn't already done. So I'm going to do now. 942 divided by 50. And I get that the density is equal to 18.84. Well, if my award is only 18.84 grams per centimeter cubed, and gold actually has a density of 19.32, the answer to my question, is the pyramid in fact gold? No, it is less dense than real gold. So what could be a reason for this? I got duped. They gave me a fake gold pyramid award. All right, now you try the problem set.